Welcome to EDU World Space.
In this problem, we're going to need to use the concept of force. So let me briefly review the concepts we're going to need before diving into the exercise. But first, remember that the acceleration is equal to the derivative of the velocity with respect to time, and that the velocity itself is equal to the derivative of the position with respect to time. Also remember that the force, according to Newton's second law, is equal to the mass of an object times its acceleration, A. So this is the total force. It's a sum of all the forces acting on an object that is called a net force. In the problem, we have a block that has a mass of 300 kilograms and has a velocity v that's equal to 0.4 t squared meters per second, where t is given in meters. T is given in seconds. And in question A, our goal is to find what is the force that acts on this object. So first, before finding the force, we're going to need to find the acceleration. And the acceleration is the derivative of the velocity with respect to time. So this is d dt of 0.4 t squared. So A is equal to 0.8 t, where I used that the derivative of t squared is 2t. Okay. And now the force is equal to the mass, which is 300 kilograms, times the acceleration, that's 0.8 t meters per second squared. So the force as a function of time is equal to 240 t newtons. Now the exercise asks us the force at time t equals 5 seconds. So at 5 seconds, we have that the force is 245 times 5, and this is 1200 newtons. So this is the answer to question A. Then in question B, the next part of the question, we need to find how far the particle moved, the block traveled in these 5 seconds. So we have that v is equal to 0.4 t squared. Now v is dx dt. And this is equal to 0.4 t squared. So dx is equal to 0.4 t squared dt. And I'm going to integrate both sides from the initial time 0, when the position is 0, the block is at the origin, to the final time of 5 seconds, where the block is at position x. So we have that x is equal to 0.4 times the integral of t squared, which is t cubed over 3, from 0 to 5. So this is 0.4 times 5 cubed over 3. And this is equal to 16.7 meters, which is the answer to our exercise.